Hello everyone, this is Dr. Akanksha Sharma and I welcome you all to my channel. So as a dermatologist, I have been asked a lot of questions regarding skincare routines, what serums to use, what creams to use, what night creams to use. But there is one question that I have been asked so many times, and that is whether or not to use a sunscreen. So what is the importance of the usage of sunscreens? And as a dermatologist, obviously, I have also tried to explain to my patients or to my relatives and friends that, okay, sunscreen is the most important step in your skincare. But I think to convince you all, today we should study the physics regarding the photobiology and photodermatology, because physics is obviously difficult to disregard. You cannot disregard physics, you cannot disregard the laws of physics. So today we will be quashing all the queries regarding sunscreens, all the queries regarding photodermatology and photoprotection. So this is going to be a video series. I'll be making 3 videos. This is the first video. So let us start with photodermatology. What is photodermatology and how it will affect our day-to-day life? Photodermatology. So first of all, what is photobiology? Photobiology is the study of UV radiation as well as the visible radiation on living matter. Living matter, all beings on the planet. What is photosensitivity? It is the abnormal response of any being to ordinary light. So any abnormal response to even the ordinary light, that is photosensitivity. So by this we can easily understand that photodermatology is the study of dermatology and how it is affected by UV radiation as well as visible radiation. So basically, we'll be studying how sunlight affects our skin. So to start with the basics, we'll be studying about the electromagnetic spectrum. What are the rays that reach Earth and how they'll affect us? So in very simple diagrammatic manner, this is the electromagnetic spectrum. All these wavelengths are in nanometers. So on the extreme left, we have 10 nanometers, and then we have the infrared radiation. Let us start. So from 10 to 200 nanometers, we have the vacuum UV radiation. Then from 200 to 290, we have UVC. 290 to 320, we have UVB. 320 to 400, we have UVA. Then we have the visible, which goes through VIB, GUR till 760, and then infrared, that is below red. This is red, and then we have infrared. So how do these different wavelengths affect how they will reach the Earth? So usually the vacuum UV radiation and the UVC radiation, they are absorbed by the ozone and stratosphere and they don't reach the surface of the Earth. The wavelengths that reach the surface of Earth are beyond UVC, that is the UVB, UVA, visible and infrared. So these are the ones that will reach the surface of the Earth, and infrared is responsible for heating. Now, very important difference between UVA radiation and UVB radiation. So this is very important and very important in the understanding of photodermatology. So here we have the differences, UVB versus UVA. So UVB was the one with shorter wavelength, right? 290 to 320. And then we have 320 to 400, which is UVA. Okay. So only 1% of UV radiation which reaches the Earth is UVB. Rest all is UVA. So UVA is the primary radiation that is reaching the Earth. 99% of all UV radiation reaching Earth is UVA. UVB is very high energy, whereas UVA comparatively has less energy. Now what about penetration? So penetration usually depends on the wavelength. More the wavelength, more the penetration. So UVA has more penetration, whereas UVB has less penetration. Now till where do these rays reach in our body? UVB, because obviously it has less penetration, it only reaches till the upper dermis. 70% of it is absorbed, 20% reaches the epidermis and 10% reaches the upper dermis. But UVA, it reaches deep. So it will go till the subcutaneous tissue, and 20 to 30% of it will reach the deep dermis. Okay, so of all the UVB radiation that is being generated by the sun, the radiation that is reaching the earth is 2 to 5%. And of all the UVA radiation generated by the sun, 95 to 98% of it will reach the earth. Because the wavelength of UVB is less, it will get scattered. So its reaching will fluctuate. Sometimes it will be 2%, sometimes it will be 5%. UVA, on the other hand, is relatively constant. So we have studied about the various rays and we now know what their wavelength is and how the wavelength will affect their penetration. So let us now study about the factors influencing skin exposure to solar UV radiation. Okay, like there will be certain factors present on the earth which will vary the solar UV radiation. But we already know that the variance will be more in UVB. UVA usually is relatively constant. So that is a very important thing to understand, that even though there will be certain factors that will decrease the radiation on earth, but out of those also UVA is usually constant and it is UVB which gets variations. Okay. Factors influencing skin exposure to solar UV radiation, first of all, is the time of the day. So noon. At noon, the rays have to traverse the least distance. For example, this is the surface of the earth. This is the sun at noon and this is the sun at any other time, okay? Be it dawn or dusk. So the distance that is traversed at noon will be the least and the distance at other times will be more. So the peak will be at around 11:30 a.m. to 1:30 a.m. in India. At dusk and dawn, there will be attenuation of the rays. There will be scattering of the light because the light will have to travel a longer distance, okay? So attenuated rays and UVB will be more attenuated than UVA. Next, number 2, seasons. So in summers, there will be maximum amount of radiation which will reach the earth. And this is only true for temperate regions, not for equator. At equator, it will be almost constant. Then we have the latitude. So the amount of rays will be maximum at the equator. So for example, this is earth, this is equator. So here the rays will be maximum and as we go up and down, the rays will decrease, okay? Then we have altitude. So altitude also matters. See, this is the sea level and then this is a mountain. This is the sun. So for example, we're talking about a person who is vacationing in the mountains and a person who is vacationing at the beach. So higher the altitude, there will be less distance to travel and there will be less scattering of the light. So that is why your dermatologist will tell you that even if you are visiting Manali, even if you are visiting Switzerland, you need sunscreen, okay? Because higher the altitude, less the scattering of light and more the requirement of a sunscreen. Then we have some particulate matter which is present in the atmosphere, like dust, clouds. So obviously that will also decrease the incident radiation. Now this is due to the Rayleigh's scattering effect. So Rayleigh's scattering effect says that the amount of scattering of the light is inversely proportional to the fourth power of wavelength. Scattering is inversely proportional to the fourth power of wavelength. So in simple words, shorter the wavelength, more will be the scatter. So we know that already though, that UVB will scatter more than UVA. We know that, but now we know the reason for it. So easier and better to understand. So even particulate matter will cause a variation in the incident radiation. Next we have clouds. Okay. So what is the percentage cloud cover? It will determine whether there is complete penetration of the UV rays or incomplete. Now, this is a very important thing to remember. Even if there is a complete cover by the clouds, it only decreases UV radiation by 50%. So even in overcast weather, your dermatologist will tell you that no, wear a sunscreen even if it is overcast. Why? Because even a complete cover only decreases UV radiation by 50%. And there are other factors too, like cloud opacity, cloud height, cloud factors like condensed water in the clouds, and solar zenith angle. What is the zenith angle? Zenith angle is the angle between the right angle and the angle at which light falls. This angle is the zenith angle. So all of these things will determine the percentage of UV penetration, and obviously a person cannot make out all these factors. So it's important to wear a sunscreen even if there is a cloud cover. Then we have another factor, which is the surface reflection. Very, very important. So there is something called the albedo. So albedo is percentage of light reflected from any surface. Actually, it is not percentage of light, it is the fraction of light. It is between 0 to 1. For example, if all the light is reflected from a surface, so the albedo will be 1. For example, for mirrors, very perfect mirrors, it will be 1. So the percentage of light reflected from any surface, for example, for the ground it is less than 10%, 0.1, albedo will be 0.1. Now, this is where things get interesting. For snow, the albedo will be as high as 80%. So, not only are you getting the incident radiation from the sun, the reflected radiation from the snow is also going to affect UV radiation. So, I will tell you this again. Even if you're vacationing in Manali or Switzerland, you need sunscreen, okay? Because snow has a very high albedo. Similarly, sand. So now we've come to the beaches. Similarly, sand. You go to Goa, you go to Andaman. Albedo can be as high as 30%. So the percentage of light reflected is very, very high. You will need a sunscreen. Even for metal roads, it is as high as 30%. Lastly, we have the ozone layer. So, okay, ozone layer causes a lot of protection, but yeah, we know that the ozone cover has been fluctuating for quite some time now. It is being said that it is recovering, but still we cannot rely on it, and I think it is better to protect ourselves with a sunscreen. With that, I thank you all for your patient listening. Please like this video, share this video a lot, I would say, because all of your friends, all of your relatives, all of your patients need to understand the importance of a sunscreen, and subscribe to my channel for all upcoming videos on sun protection. Thank you so much.